Energy is everything, surrounds us everywhere in light sun, in movement wind, in ray fire, in beating our hearts. Without energy, there would be no life, no movement, and even no existence universe itself. But what actually is energy? Why term this is used in physics, chemistry, biology, and even in daily life, and its exact definition still remains mystery. Especially striking is energy hidden in small atoms. Imagine that every object, which you see, every particle in your body, is miniature reactor in which hides enormous power. Where does it come from? How small atom can release so much energy, which suffices to cause destructive explosions, or conversely, to supply whole humanity with electric energy? Today we will learn what energy is on fundamental level, why atoms are true giants of energy, and how humanity learned to use this power. Energy is not only physical term, it is heart-whole universe. Its driving force penetrates every atom, every galaxy, creates and destroys worlds. But here is what is interesting. Despite that energy is basis every existence, physicists still cannot give it unambiguous definition. We know how to measure it, how it is transferred and transformed, but what it is on most basic level remains mystery. Imagine that you throw ball. In moment, throw your hand gives it kinetic energy. Ball rises up but gradually slows down. Its kinetic energy changes to potential. Then it falls and process proceeds in opposite direction. But energy nowhere disappears, only changes form. This law conservation energy, one of most fundamental principles physics. It says that energy does not arise from nothing and does not disappear without trace, but only changes from one form to another. Therefore, when wood burns in campfire, its mass does not disappear, but changes to heat and light. Most surprising is that energy is contained absolutely in everything, in every particle, in every atom, even in empty space. Light is stream photons carrying energy. Bus driver is energy fuel changed to mechanical work. Even we ourselves exist thanks to energy obtained from food. However, most amazing is energy hidden in matter itself. According to equation Einstein E equals mc squared, every mass is pure energy. This means that even in the small piece matter is huge amount energy. For example, if one could completely convert only 1 gram matter into energy, it would suffice to supply whole city with electric energy for several days. If we look deeper, we can discover even more amazing fact. Energy existed even before appearance matter. At moment Big Bang, from pure energy, first elementary particles arose, which then formed atoms, stars, and finally ourselves. It turns out that everything we see around us is result transformation energy chaos, which gains structure. One might think atom is something small and harmless. In reality, it is like spring, in which hidden is enormous energy, so great that if one could release all energy contained in 1 kilogram matter, it would suffice to power Megapolis for several months. But where does such power come from in these small particles? If we look inside atom, we see that it consists of nucleus and electrons surrounding it. But all its mass and thus energy are concentrated in nucleus, small cluster protons and neutrons. Paradox arises. Protons have positive charge, so logically they should repel each other. After all, if we try to bring two magnets with same poles close, they repel. So why does nucleus not disintegrate? Answer lies in strong nuclear interaction, most powerful force in universe, which holds protons and neutrons together, overcoming their electrostatic repulsion. This interaction is true titan of energy. It acts at incredibly small distances of only few femtometers, i.e., trillionths parts millimeter, but energy is huge. Thanks to this force, nuclei exist in stable state. But if it is released, consequences will be destructive. Now let's return to equation Einstein E equals mc squared. It says that mass is only hidden form energy. Every particle having mass contains astronomical amount energy. For example, piece uranium nail size can during fission release as much energy as obtained by burning hundreds tons coal. Curiosity. If I could convert all my mass, say 70 kilograms, into pure energy, it would suffice to power whole Earth for several hours. In reality, this is still impossible. Such processes require special conditions that occur, for example, in stars or nuclear reactors. Why nuclear energy is so powerful? Main secret nuclear energy lies in that mass. Nucleus is somewhat smaller than some masses, its individual parts, protons and neutrons. Phenomenon is called mass defect, and difference between masses is released as energy in nuclear reactions. To imagine this effect, imagine wall bricks in which mortar holds bricks. If you remove mortar, wall collapses, releasing energy. In atomic nucleus roll, this plays strong interaction. Binding particles is so strong that when they are separated, reserve energy is released. Exactly this happens during nuclear fission in atomic bombs and reactors, or during fusion in core sun and hydrogen bombs. For example, sun is true thermonuclear reactor. In its core, under huge pressure and temperature, millions degrees hydrogen atoms collide and fuse, forming helium. This process is accompanied by energy release that heats and gives life to all organisms. Every second thermonuclear fusion sun releases as much energy as humanity consumes in several million years. If one had to choose most powerful force in universe, probably would think of gravity. After all, it holds planets, stars, even entire galaxies together. However, gravity, although seems impressive, is actually a puny compared to other type interaction, strong nuclear interaction. It is precisely this force responsible for nuclei not disintegrating, and thus for existence all matter. But what is this force? Why is it so powerful, and how exactly produces energy released in nuclear reactions? Protons in atomic nucleus have positive charge, and we know same charges repel. If strong interaction wasn't there, every atomic nucleus would immediately decay, and thus atoms simply wouldn't exist in nature. But nature protects itself. Strong nuclear interaction. It is so powerful that more than compensates electrostatic repulsion between protons and strongly binds them to neutrons. Without this force, atoms, molecules, even stars simply wouldn't exist. Hear how much stronger this interaction is compared to other fundamental forces. Gravity is outmatched by strong interaction by 10 to the power 38. Electromagnetic interaction, generally about 100 times weaker, and weak interaction responsible for radioactive decay is even weaker. In other words, strong interaction is true titan among fundamental forces nature. This powerful force doesn't operate like forces we know such as gravity or electricity. It acts only at very short distances, order 1 or 2 femtometers. This is 100 times less than size atom itself. If particles are close to each other, interaction holds them with enormous force. But if they start moving apart, force quickly weakens. Imagine 2 climbers climbing steep wall holding rope. When inside, close rope is strong, not breaking, but as soon as they move apart, connection between them disappears. Exactly so strong interaction works. Acts only when close, but its force is incomparable large. There arises also interesting question. If strong interaction is so powerful, then how is it transmitted? Who is responsible for its action? Answer is gluons. These particles are carriers strong interaction. They can be imagined as invisible glue that binds protons and neutrons. Gluons act according to very strange laws. They not only bind protons and neutrons, but also can interact among themselves, which is not typical for photons, for example. They are responsible for creation quarks, smallest components, protons and neutrons. Without gluons would be no strong interaction, and without it, universe would be empty. Cold space without atoms and life. When we talk about release atomic energy, most people imagine nuclear explosion, blinding flash, huge fireball, shock waves. Power nuclear weapons is striking. But what is behind this process? How exactly nucleus collapses, releasing such incredible amount energy? For example, nucleus uranium-235 of most unstable elements, nature resembles overly stretched spring, ready to snap. As soon as neutron hits it, balance is disturbed. Nucleus literally cracks open and splits into 2 new elements. This process is accompanied by release several additional neutrons that immediately run to neighboring atoms, causing their decay. This is nuclear fission process in which nucleus-heavy atom decays, releasing energy contained in bonds between its particles. At first glance, seems nothing special happens, simply atom splits into 2 lighter ones. But here lies big secret. If some masses these fragments and emitted neutrons turns out to be less than original nucleus mass. Where did difference go? Missing mass turns into pure energy, and even its small part can cause huge energy release. For example, 1 gram fissile uranium releases as much energy as burning 3,000 tons coal. Completely destroying just 1 kilogram atomic nuclei, one can provide electric energy for 1 million people for several days. Simply put, when nucleus splits, it releases huge reserve energy accumulated inside it for billions years. How chain reaction forms. Nuclear fission is only single event, but if process is not stopped, it starts intensifying like snowball. Fact is that at each fission, several neutrons are emitted that in turn collide with neighboring atoms, causing their breakup. This mechanism is called chain reaction. If number new fissions grows exponentially, reaction becomes uncontrolled. But if process is limited and regulated, for example, by absorbing part neutrons, one can obtain controlled chain reaction that becomes base energy for nuclear power plants. Not all elements are, however, suitable for nuclear fission. For example, common uranium U-238 is almost incapable to sustain chain reaction. Uranium-235, however, is true master in this field. When we speak about energy, most people imagine it in known forms: solar heat, wind movement, wood burning. It turns out energy behaves there totally differently. At macro level, energy is ability to perform work, accelerating car, heating water, lifting load, but at quantum level, it is not so simple. Micro-world energy is not transferred smoothly, but exists in discrete portions called quanta. For example, electron and atom can't be between levels, just like car can't be between floors parking. It is either at one level or another, and if it receives energy, immediately jumps to higher level without intermediate states. And when it returns, emits photon particle light. This phenomenon is called quantum leap and lies in base functioning lasers, LEDs, and even photosynthesis. Imagine now that you climb stairs, but can stand only on steps without possibility to stop in between. In quantum world, all transitions energy are organized exactly this way. In everyday life, we are used to think if you take everything from box, it will be empty. But in quantum vacuum, it is different. Even in emptiest space, energy is boiling. According to Heisenberg, uncertainty principle, vacuum is not silent emptiness, but bubbling ocean virtual particles appearing and disappearing with fantastic speed. These smallest energy explosions are so real they affect even universe. For example, move mirrors in absolute vacuum create small gravitational fluctuations which could give start entire universe. Here another example. Imagine you look at absolutely calm surface lake, but suddenly notice barely visible waves and bubbles. That is exactly how quantum vacuum looks. It is never completely empty. If we go even further, appears interesting question. What if whole universe is only fluctuation energy? One hypothesis says Big Bang happened precisely thanks to quantum tunneling. Quantum energy literally broke barrier vacuum and created something. In reality, everything that surrounds us, atoms, light, gravity, are different manifestations of this same quantum energy. Even mass particles exist only due to interaction with quantum field Higgs. It is not only property matter, energy is fundamental building block reality. Let's now return to atom itself. At first glance, it seems tangible, dense nucleus and small electrons orbiting around. But if we disassemble, it turns out that 99.99% atom is empty space. So what makes it real? Answer is energy. Perfect example is soap bubble. It seems real, but inside there is almost nothing, only surface and densest layer molecules. Same as with atom. It exists due to energetic interactions, not due to solid matter. As a result, turns out that everything we see, hear, and feel is nothing else but vibrations and transformations of quantum energy. So what do we finally have? Energy is most mysterious essence in universe. It has no shape, weight, or color, but controls everything from work atoms to movement galaxies. Atom is miniature reservoir, colossal energy. Atomic nucleus is held by forces millions times stronger than gravity. Breaking these bonds, as in nuclear reactions, leads to release gigantic energy. Strong interaction is main player in world atoms. It holds protons and neutrons together, and thanks to it, matter exists in form we know. Energy in quanta exists in form. Quanta is transmitted in portions, creates virtual particles, and even fills vacuum. We ourselves are energy. Every cell our body, every atom is rotating quantum process. Even mass is nothing else but frozen energy linked with quantum fields. And finally, main conclusion, energy is not only tool but base reality. Everything we see, feel, and even what we are is form manifestation energy hidden in structure universe.